For the extra credit for quiz 6, it's number 3, which is it took 25 milliliters of NaOH to reach the endpoint of a titration of 100 milliliters of 0.2 molar acetic acid. The Ka of acetic acid is 1.8 times 10 to the negative fifth. What is the pH at the endpoint? So we're trying to find the pH at the endpoint, and so we have to start off by finding the amount of moles of acetic acid. So you start off with 100 milliliters, convert it to liters, and multiply it by the molarity ratio of acetic acid, which is 0.2 moles over 1 liter, and you get a value of 0.02 moles. And so we add that to a ice table. So we're adding hydroxide to acetic acid, which is NaOH, but I took out the Na to make it easier, and it goes to CH3COO minus and water. So if you start off with 0.02 moles of acetic acid and it's the endpoint, you have to have the same amount of moles of NaOH to make it the endpoint. So you have 0.02 moles of each, and obviously they're both the limiting reagent because they have the same amount of moles. So you subtract 0.02 on both sides, and you add the 0.02 to CH3COO minus, and obviously you get 0.02 moles. So we have to find the molarity for that, and the new volume would be the 100 milliliters plus the 25 milliliters of NaOH, which would give us a value of 0.125 liters. And if we divide the moles over the total volume, we get a value of 0.16 molarity for the CH3COO minus. So we have to make another ice table and add that to the table, and you add water to it and you get acetic acid plus the hydroxide, and you subtract X because it's 1 mole, add X, both 1 mole, and at equilibrium it'd be 0.16 minus X, X, and X. And we also assume for this one that X is small compared to our Ka. So after that, we have to set up our Ka expression, and we have 1.8 times 10 to the negative fifth, and that is equal to the X squared over the 0.16, and then we multiply and then square root and get an X value of 1.7 times 10 to the negative fifth, which is also our OH concentration. So we could find the POH from that and take the negative log of 1.7 times 10 to the negative 3, and we get 2.77. To find the pH from that, we subtract from 14, and we get a final answer of 11.23 pH.